Okay, we're going to start probably the last video for section 4.2 and 4.3. So we just got done with the conjugate zeros theorem. We're going to look at the rational zeros theorem, and then we'll look at two examples that should hopefully clarify this. Let f of x be a function, and f of x is a polynomial, and where each coefficient is an integer, and a sub n and a sub 0 are not 0. Okay, if p over q, which is in lowest terms, is a rational zero of f, then p is a factor of a sub 0 and q is a factor of a sub n. A rational zero is a fraction that is a zero. Okay. So what does all this mean here? Well, basically what you're trying to do is you're trying to get a list of fractions and that are zeros, that are possible zeros. So let's maybe take a look at an example here. For example, suppose f of x is equal to 2x cubed plus 3x squared minus 11x minus 6. Okay. Each coefficient has to be an integer. That's important. Okay, so if I had like a minus 11 over 6 or something, I could not use this theorem. And that would be a really hard thing to solve for. Okay. So the fact that we can use the rational zeros theorem on something like this makes this problem a lot easier than what it could be. So p is a factor of the last coefficient, negative 6. 1 and negative 1 are factors of any number, so you're always going to have plus or minus 1. Okay, plus or minus 2 going to negative 6. Plus or minus 3 going to negative 6, and plus or minus 6 going to negative 6. Q is always a factor of the first coefficient, a sub n. Okay, so plus or minus 1 goes in any factor. Plus or minus 2 are factors of a sub n, and that's it. Okay, so the possible rational zeros of f would be all the numbers of the form p over q. 1 over 1, plus or minus 1 over plus or minus 1 is plus or minus 1. Plus or minus 2 over plus or minus 1 is plus or minus 2. Plus or minus 3 over plus or minus 1 is plus or minus 3. Plus or minus 6 over plus or minus 1 is plus or minus 6. So now move on to if 2 or negative 2 are factors are in the denominator. Okay, so plus or minus 1 over plus or minus 2 is plus or minus 1/2. Plus or minus 2 over plus or minus 2 is plus or minus 1. We've already got 1 and negative 1 both listed. We don't have to list those again. Plus or minus 3 over plus or minus 2 is plus or minus 3/2. And plus or minus 6 over plus or minus 2 is plus or minus 3. I've already got 3 and negative 3 listed. So I've got 1, 2, 3, 4, 5, 6, 12 possible rational zeros of f. 12 of them. And of course, don't forget about the plus or minus there. Okay. So what I would do is, if the 0 is a fraction, it's gonna be one of these listed, one of these 12 numbers listed. Okay. And if it is not a fraction, it is an irrational number or a complex number. Then it is not going to be on the list, and that makes the problem way more difficult then. So let's try it out here. F of 1, f of 0 is negative 6. F of 1, 2 plus 3 is 5, minus 11 is negative 6. Minus 6 is 12. Okay. Negative 12. Okay. F of negative 1. 2 times negative 1 is negative 2. Plus 3 is 1. plus 11 is 12, minus 6 is 6. Okay, let's try 2. 2 cubed is 8, times 2 is 16, plus 3 times 2 squared is 16 plus 28, minus 22 is 6, and then minus 6 is 0. Okay, so 2 is 0. X minus 2 is a factor then. And I just go right down the list here of all these rational zeros. So knowing that 2 is 0 means that x minus 2 is a factor, and I know one of the factors then. Okay, so I can further factor this. 2 is a 0, and so 0 would be left over. 2 goes down, and I just pull all the constants in front of the terms in 2 and 3 and negative 11 and negative 6. So 2 comes down, 2 times 2 is 4, 3 plus 4 is 7, 7 times 4 is 14, minus 11 is 3, 3 times 2 is 6, negative 6 plus 6 is 0. Okay, so I get 2x plus 7, 2x squared plus 7x plus 3. F of x is 2x cubed plus 3x squared minus 11x minus 6, and that's what I got there for f of x. I've started to factor this. Okay, x minus 2 times 2x squared plus 7x plus 3. 2x squared plus 7x plus 3 factors further as 2x plus 1 times x plus 3. X equals 2, x equals 1/2, and x equals negative 3 are the 3 zeros then. Notice how all 3 of these numbers are listed in the possible rational zeros. Okay, so if I would have come up with like negative 1/2 first, I would have found it would have returned to 0, indicating that negative 1/2 is a 0, and I would have had something different than to factor. Still would have produced zeros. There are 2 of them. Okay, which would be 2 and negative 3. Okay. How about f of x equals 3x to the 4th plus 10x cubed minus 12x squared plus 70x plus 25. Well, p is a factor of the last coefficient, 25. So the factors of 25 are plus minus 1, plus minus 5, and plus minus 25. Q are the factors of the first coefficient, a sub n, plus minus 1 and plus minus 3. So possible rational zeros of f contain all the numbers of the form p over q. Plus or minus 1 over plus minus 1 is plus minus 1. Plus minus 5 over plus minus 1 is plus minus 5. Plus minus 25 over plus minus 1 is plus minus 25. Okay, and then we got plus minus 1 over plus minus 3 is plus minus 1/3. Plus minus 5 over plus minus 3 is plus minus 5/3. Plus minus 25 over plus minus 3 is plus minus 25/3. F of 1 is equal to 96, if you were to plug that in and simplify. F of negative 1 is negative 64. F of 5 is 3,200. So all 3 of those numbers are not 0. F of negative 5 gives me 0, though. Okay, so x plus 5 is a factor. And notice how negative 5 would be on this list. Okay, I've got 12 possible rational zeros of f. Okay, so it makes the most sense to be guessing and checking only on this list. If I try plus or minus 3, it doesn't work because plus or minus 3 is not on this list. Okay, plus or minus 1/3 is, but that's not the same as plus or minus 3. Okay, so I've got x plus 5 as a factor, And so I can take the original function divided by a factor x plus 5, and negative 5 is a 0, and therefore 0 is left over. And I take the coefficients in the function and arrange them into a table form. 3 comes down. 3 times negative 5 is negative 15. 10 minus 15 is negative 5. Negative 5 times negative 5 is 25. Negative 12 plus 25 is 13. 13 times negative 5 is negative 65. 70 minus 65 is 5 times negative 5 is negative 25. 25 minus 25 is 0. Okay, so 0 is left over. That's good. Now I'm more interested in what's to the right of 0, or what's to the left of 0, because that's going to leave me with my new expression. So what I get is when I divide by 5, let me just show you here, using the coefficients from the table, and the degree of the polynomial is always 1 less than the original. Okay, so I've got a degree 3, not a degree 4. And so here's what I got now for f of x. Okay, let's let g of x be equal to 3x cubed minus 5x squared minus 13 plus 13x plus 5. And we'll use the rational zeros theorem again. P is the factors of 5, plus minus 1 and plus minus 5 are the factors of 5. And Q is the factors of the first coefficient, which is 3. Plus minus 1 and plus or minus 3 are the factors. So the possible rational zeros of G are plus or minus 1, plus or minus 5, plus or minus 1/3, and plus or minus 5/3. Okay, if I plug in 1 into G, then I get 16. 3 minus 5 is negative 2, plus 13 is 11, plus 5 is 16. G of negative 1, it gives me negative 16. G of 5 gives me 320, if I were to check that. G of negative 5 gives me negative 560, if I were to check that. G of 1/3 gives me approximately 8.89, if I were to check that. Okay, G of 1/3, G of negative 1/3 gives me 0. And so x plus 1/3 is a factor. X minus negative 1/3 would be a factor. Or 3x plus 1 would be a factor, same thing. So I've got x plus 1/3, or 3x plus 1, and looks like I've decided to use 3x plus 1. Although x plus 1/3 works perfect here. So I got the what is g of x divided by 3x plus 1 gives me negative 1/3. 3 comes down, multiply 3 by negative 1/3, that gives me negative 1. Times negative 5 is negative 6. Negative 6 times negative 1/3 is 2. 13 plus 2 is 15. Times negative 1/3 is negative 5. 5 minus 5 is 0. I should be getting 0 left over. That's good. And so when I divide g of x by 3x plus 1, I get 3x squared minus 6x plus 15. Okay, so negative 1/3 would be another 0. And here's what I got so far. I got x plus 5 times 3x plus 1 times 3x squared minus 6x plus 15. To find the zeros, the two remaining ones, 3x squared minus 6x plus 15 equals 0. Of course, I can easily get the zeros here for these other two. Means I have to use the quadratic formula. The opposite of b is 6 plus or minus the square root of b squared. Negative 6 times negative 6 is 36 minus 4 times 3 times 15 all over 6. 2 times 3 is 6. Okay, so I got 6 plus or minus the square root of negative 144 all over 6 gives me 6 plus or minus 12i over 6. That gives me 1 plus or minus 2i. Okay, so these would be complex zeros, and still part of my answer. These two zeros along with these two zeros give me 4 zeros total. I've got a degree 4 polynomial here initially, so I would know right away that I'm going to have 4 answers. It's just, you know, without doing this procedure though, I have no idea what these 4 numbers look like. And so anyway. Okay, the homework is on page 14, section 4.2, and then page 221, section 4.3. So be sure to look at those problems for me.